So good morning, everyone, and thank you so much for joining our session at this early hour. So today we're going to talk about how threat actors can abuse software development platforms to infiltrate our systems and evade detections. Think about your VS Code, Python, even GitHub. We'll explore how these tools can be abused by threat actors. So today we have 6 different case studies. Each is going to touch upon a different technique to abuse an IDE. We will explore the stories behind the case studies, talk about how the techniques work, and we'll also explore what we can do to detect and prevent such abuse. We will also show you a live demo of one of the techniques, how the abuse of VS Code CLI looks like from the side of the attacker. And we will finish the presentation with some final key takeaways we have from all of our research. So the whole idea behind this session started with a breach. On our day-to-day work, we do threat hunting on our customers' environments. And one day, we had an alert about some suspicious interactive activity. And that alert came from an environment that belonged to a government entity located in Southeast Asia. So naturally, that really intrigued us, and we started investigating. And inside the network, we saw a lot of indications for exfiltration activity. So I started investigating. I wanted to understand what was the origin of all of that activity. And I saw that a lot of the malicious commands were executed by a process of VS Code CLI. Now, that was odd because it was the real legitimate VS Code CLI and not some renamed malware. So initially I thought, okay, maybe it is a case of injection or DLL sideloading, but I couldn't find indications for either of those others. So I was left there thinking, how is that completely legitimate VS Code process is being abused to execute all those malicious commands? I'm going to leave you hanging with that question for a little bit, but I promise we will come back to that puzzle later in the presentation. But that whole incident got us thinking. In what other ways can threat actors abuse software development platforms to gain a hold of our systems? And even before that, why threat actors would even want to abuse IDEs? Well, I'm glad you asked, because there are multiple reasons. First, IDEs can function as a great infection vector. Threat actors can use social engineering to convince users to execute malicious code, or to trick users to download and install malicious packages. A second reason is that a lot of IDEs come with built-in capabilities to control the machine, which means that if an attacker can get a hold of an IDE, they may not even need to put in the effort to deploy malware. Also, because IDEs are, of course, legitimate applications that a lot of people use, if an attacker can abuse one as part of an attack, it can make the attack a lot harder to detect. And if the goal of the attackers is to gain a hold of source code, what is a better target than the main tool developers use every day to write that source code? So now that you understand why threat actors would want to abuse IDEs, let's get into some case studies. So as I said, we have 6 different case studies. Each one is touching upon a different technique to abuse an IDE. And you might notice that quite a few of those case studies were performed by North Korean threat actors. It looks like they really like to abuse IDEs as part of their attack playbook. And we found a lot of cool examples performed by them. Okay, so now it is time for our first case study, how threat actors can abuse malicious projects to infiltrate our systems. So I'll pass the stage to Daniel for our first case study.
Thank you, Tom. So let's have a look at how threat actors abuse Visual Studio and Visual Studio Code projects for their malicious purposes. So this research, evidence suggests that it was conducted, the malicious activity in this research was conducted by a cluster of activity that we suspect is originating from North Korea. Now, they were conducting fake job interviews for software developers in the cryptocurrency sector. And they were delivering these malicious C# projects that they hoped will be executed in these IDEs. Now, you might be wondering, why software developers? Well, software developers hold a lot of sensitive data. They have a lot of access to a lot of sensitive data, to source control, so they might be a valuable target for extortion and also for stealth of intellectual property. And why the cryptocurrency sector? You also might know that North Korea are under heavy sanctions, and they invest a lot in their cyber warfare. And in that cyber warfare, they really focus on trying to fund the regime by conducting these cryptocurrency heists and also trying to steal cryptocurrency. Let's break down the attack stages. So how did it work? Well, first of all, the victim would download a malicious project. Then they would open up the project in their VS Code or Visual Studio, press build to compile all of these source code files into a working application, and in the background, a malware was being downloaded, granted with execution permissions, and executed in the background. And we took one of these malicious projects and open it in our lab in an IDE. And as you can see, there are two distinct malicious files. And these files do exactly what I mentioned. They connect to the attacker's command and control server and silently download and execute malware. Now, looking at the bigger picture, this is how we discovered a previously undocumented variant of a Windows malware called Koi Stealer. We found previously undocumented macOS variant of this malware, and this is also how we witnessed the attackers using OSA script. So OSA script, it's a built-in feature within macOS, and the attackers were using it in the context of tricking the victim into typing in their password. And the victims were thinking, okay, so this looks like a legitimate Visual Studio code or Visual Studio update, but in fact, it was all part of the malware's infection chain. Now, how do we prevent from these malicious executions from being executed on our environments? Well, first of all, it's always a good idea to scan the code. I mean, when you open an unknown project, you can always review the code, scan it manually or automatically before you're executing it. And if you're still unsure, there's a built-in feature that's called restricted mode in VS Code. And what it does is it's eventually limits some of the functionality of third-party projects, like let's say internet connectivity or execution of some commands. So it makes this more contained and safer. And on the proactive side, it's really important to hunt for suspicious activity in your environment. And in this case, hunt for suspicious activity that's originating from Visual Studio Code IDEs, and also hunt for suspicious activity that is performed by OSA script. Okay, now that we know how threat actors are abusing VS Code and Visual Studio and doing all of these malicious projects, I will hand over the mic back to Tom, who will talk about low-code development platforms.
Thank you, Daniel. So now I want to play a little game with you. I'm going to show you a few screenshots, and I want each of you to think to yourself, were those images taken from a malware control panel or a legitimate application? We can see here a lot of different functionalities, capabilities to take screenshots, interact with Active Directory, get data from web pages, get clipboard data, do stuff with encryption and decryption. Those are capabilities we will find in most malware today. Sometimes the line between a legitimate application and malware only depends on the intent of the user. Now, if any of you have already recognized, this is of course not malware. These were taken from Microsoft's low-code platform called Power Automate. A low-code platform provides the user a development environment to create application software through a graphical user interface. Basically, it enables the user to create automation without needing to know how to program. In this session, we are going to specifically focus on Microsoft's Power Automate, but there are a lot of different low-code platforms available out there, and what we are saying is relevant for all of them. So the case study we are going to focus on today was reported by Microsoft at the start of 2020. They reported about an attack they were investigating, in which the attackers infiltrated the network and took control of the Power Automate platform to exfiltrate some data. They did not publish a lot of information about the attack, but enough that we can get the gist of it. And this is the flow of the attack. in order to get access to the environment, the attackers used a password spray attack. And because multi-factor authentication was not enabled in the environment, that was enough for the attackers to get access. After that, the attackers used different e-discovery tools to search for more passwords to steal, and also for intellectual property to steal. Using those passwords, the attackers also managed to get access to the Microsoft Power Automation platform that was installed on various Windows machines across the network. They used the Power Automate platform to create automation, which allowed them to basically exfiltrate all the data they wanted from the environment. And because, of course, Power Automate was trusted in the environment, it made the attack a lot harder to detect. Microsoft reported that the attackers were persisted in the environment for at least 240 days. And because, as I showed you, Power Automate gives the user a lot of functionality, the attackers did not need to deploy any malware as part of the attack. Power Automate gave them all the capabilities that they need to perform the attack. And I want to show you how easy it is to use Power Automate for exfiltration. So this is like a simple demo of a flow that I created myself to do some very simple exfiltration. And it works like that. First, I told Power Automate to get all of the different Word documents, TXT files, Excel files, and PDF documents from the user's documents folder. After that, open an FTP connection to your preferred FTP service. And after that, just upload each file to the FTP service. Very simple. And I even programmed the flow to wait 5 minutes between each upload in an attempt to evade any exfiltration detections. So now that we see how simple it is to use Power Automate for exfiltration if we want to, let's talk about what we can do to try to detect and prevent such abuse. So first of all, it is very important for organizations to use multi-factor authentication inside their network. If the victim in a Microsoft report had multi-factor authentication enabled, probably none of that story would have happened. We also recommend to enable system login for your low-code platform. In the worst case scenario that you are hit with a similar attack, it will greatly help you to investigate and understand what happened. And if you are using a low-code platform in your network, hunt for any suspicious activity being performed by the low-code platform. Okay, so now that you understand what is the threat behind low-code platforms being abused, let's get into our next case study. And I say for the next one, let's change it up a bit and choose one at random. So let's start our Wheel of Fortune. And I worked really hard on that animation. Okay, and totally randomly, the one that we got is malicious extensions. So now I'll pass the stage to Daniel again to talk to you how threat actors can abuse malicious VS Code extensions.
Thank you, Tom, and how convenient that these are in fact our next slide. It wasn't planned or anything. Let's talk about malicious VS Code extensions. Now, what is VS Code? Well, VS Code is eventually this extension-based code editor. All right, it relies heavily on extensions, and extensions makes the developer's life much easier. Extensions can be some nice themes for your IDE, debuggers, different support for different coding languages, etc., which is great, right? But it also can be potentially dangerous. There are applications that require high privileges to run. They can also execute arbitrary code and other bad stuff. So this is not so great. And this is the main page of the Visual Studio marketplace. So we can see all of these extensions by trusted developers with familiar icons, and most of them have really good ratings, and some of them even have millions of downloads. But what if I told you that millions of downloads is not enough by itself to indicate whether an extension is malicious or not? Research from recent years by our peers showed that different extensions with millions of downloads were in fact malicious. And here are some examples. We can see that most of these extensions also have millions of downloads. They have really familiar names and really familiar icons, right? And yet, all of them were found malicious. Now, how do we avoid, or at least try to avoid, all of these malicious extensions? First of all, of course, download extensions by trusted developers, by trusted vendors. You can go to the developers page and see that you were not misled by, I don't know, like this familiar icon or familiar name, and you're in fact downloading the extension that you intended to. Also, there's a built-in feature to enable only signed extensions, so leave that on. A lot of extensions are also open source, so you can go and review the code by yourselves and see if it's malicious or not. Also, it's important to check the permissions each extension requests before you install them. I mean, if you're installing an extension whose sole purpose is to give you some nice themes, but it requests camera access or microphone access, it could be a little bit suspicious, I think. Okay, we reviewed malicious extensions, and for the next use case, Tom will show you how threat actors abuse GitHub to deliver malware.
Thank you again, Daniel. So the next case study we are going to touch upon is called Contagious Interview. You might have heard about this campaign in one form or another because there were a lot of different reports about it in recent months. We assessed that the threat actor behind the Contagious Interview campaign operates on behalf of North Korean state interests. And as part of this campaign, the threat actor is targeting software developers through different job search platforms, posing as prospective employers. As part of the campaign, they are setting up fake technical interviews with a victim. And in the interviews, they are trying to convince the victim to execute malicious code as part of the interview. One thing we noticed about this campaign is that the threat actors are mostly targeting developers in the cryptocurrency sector. Now, in order to deliver the malicious code, the attackers are abusing GitHub. And they may abuse GitHub in one of two different ways. They could either create their own malicious repository, which of course has malicious code inside it, or they could inject malicious code into another repository of a completely legitimate developer by suggesting commits to that repository. And from our investigation, we saw that those commits get approved quite a lot. We are not the only ones who noticed something suspicious about those repositories. In the images here, you can see comments on a couple of those malicious repositories from users who are exposed to the malicious code as part of a job interview. And they write here how this is a scam repository, and they wonder who is behind this repository. And this is how one of the malicious suspicious commits looks like. So you can see they're trying to commit to the repository what looks like very suspicious code. Now, over time, in their attempts to hide under the radar, the attackers change the code that they are hiding inside the repository a little bit. Now they are using, now instead of having all of the malware's code inside the repository, they are saving it inside the cookie of a remote domain. And they're only using a couple of malicious lines of code inside the repository. One line to get the cookie from the remote domain, and the second line to execute the JavaScript code inside the cookie. This method is, of course, pretty efficient, as it is a lot harder to notice only a couple of malicious lines of code inside a huge repository. And if you are curious, this is how the code inside the cookie actually looks like. So you can see it is some very obfuscated JavaScript code. But even though the attackers really try to hide in plain sight, if we know what to look for, we can actually find those malicious repositories pretty easily. As part of my investigation, I created a query to search for the line that is responsible to execute the JavaScript code from the cookie. And to my surprise, this line is very indicative of malicious code. All of the different results I got from my query are from different malicious repositories. And some of those repositories look quite good. I took a few screenshots of some of the repositories, and as you can see, it is evident that the attackers made effort to make the repositories look as legitimate as possible. Now, in this session, we are not going to do a deep dive into all of the different stages after the abuse of GitHub, but just so you get an idea, this is like the general full attack flow. So as we talked about, the attackers first create or infect a repository with malicious code. After that, they get the user to execute the malicious project, usually via the guise of a fake job interview. The malicious project then executes a JavaScript backdoor called Beavertail. And this is actually the malicious JavaScript code that I showed you previously in the images. The Beavertail backdoor then downloads another malware, a Python backdoor named Invisible Ferret, which basically grants the attackers full control of the infected machine. This flow is pretty efficient and very powerful. And it probably makes you ask, what can I do to prevent myself from being infected by malicious GitHub packages? So first of all, we need to validate the project we download. Is the project trustworthy, or is something looks suspicious to us? We need to check for signs of fake accounts. Some of the accounts of the threat actors that we saw during our investigation did not look legitimate at all. Some of them look like they were created yesterday with no other activity aside from that one suspicious repository. But maybe the account of the author does look legitimate. We want to also review the project contributors. Check for suspicious commits. Maybe we see commits by some suspicious looking users. And after all of that, of course, it is always smart to execute untrusted code inside a safe environment, like a virtual machine. So now that we understand how GitHub can be abused by North Korean threat actors, let's get into our next case study, how attackers can abuse Python packages. So I'll pass the stage to Daniel again.
Thanks again, Tom. Okay, Python packages. So in this research, we witnessed how threat actors are abusing Python packages to deliver what was a previously undiscovered malware for Linux that we called PointRat. The cluster of the activity behind this is a group that we track as Gleaming Pisces, also originating from North Korea. They're also known as Citron Slit or Apple Juice. And in our case, it was also targeting software developers. But generally speaking, this threat group is really focused on crafting these cryptocurrency-related lures to trick victims into downloading multi-platform malware. Our malware had strong code similarities with another malware which was written for macOS and previously attributed to Gleaming Pisces. Now, they were distributing this malware by uploading malicious Python packages to the PyP code repository, which is this really large code repository for Python packages. Looking at the attack stages, we see the known drill of downloading this time a malicious package, and most of the times these malicious packages worked and did the job that they were intended to, but also when they were imported, they also downloaded malware in the background and again granted the execution permissions and executing it. So we took one of these packages to see how it looks from the inside. We took a package called color.txt, this specific version of it, extracted its content, and browsed this os.py file. And this is what we saw inside, and we immediately understood that this can't be really good, right? So the natural next step was taking this string and deobfuscating it, and this is what we found. We can see the known routine again of connecting to a command control server, silently downloading malware, and executing it in the background. Looking at the bigger picture, this is how it looked like. So we have these malicious processes of the terminal that are being spawned under Python 3, and they're spawning the curl, the legitimate utility, and silently downloading the malware and executing it in the background. How can we prevent from installing all of these malicious Python packages, or at least minimize the damage? First of all, as usual, review the code. Second thing, when we start new Python projects, it's important to use a virtual environment for each Python project. This way, even if we unintentionally install the malicious Python package, it can be contained and not infect other Python projects system-wide. Also, when you open your terminal and you type in pip install to install a new Python package, try to be focused and just avoid typos, because attackers are relying on it, and they are purposely they're calling their malicious packages with names that are similar to known legitimate packages. Also, on the proactive side, it's important to monitor, as we saw in the previous slide, to monitor for suspicious activity originating from the Python process, and when possible, in your organization, you can always choose to manage a cached Python server. What I mean by that is that you can take a cache server locally in your organization, pre-audit specific versions that you need for your Python projects to work, and that way your developers won't have to connect to an external resource each time they want to install a package, but rather install it from this local cache server. Okay, so that's it for Python packages, or malicious Python packages, and I would like to hand over the mic back to Tom, who will show you a live demo of how threat actors abused VS Code CLI.
Thank you, Daniel. So I want now to take you back to the story I started this presentation with. Just to remind you, I was investigating an attack by an APT in which the attackers abused the VS Code CLI process to execute some very malicious commands. As part of my investigation, I was trying to find, before that, we assessed that the threat actor behind this attack is a group we track as stately Taurus, which operates on behalf of the Chinese nation-state interests. As part of the attack, the attackers targeted a government entity located in Southeast Asia. And it looks like the goal of the attack was to collect as much data as possible for the purpose of espionage. So as part of my investigation, I was trying to find indications for exfiltration activity. Of course, you can see I found it. I saw the attackers collect probably hundreds of different sensitive and classified documents from the infected environment. They archived all of the files and they uploaded them to Dropbox, which is, by the way, another good example of how attackers can abuse legitimate services to hide under the radar. So I was trying to see what was the origin of all of that exfiltration activity, and I saw that a lot of the malicious commands were executed by a process of Visual Studio Code, completely signed and verified process. Didn't find any signs of injection or DLL sideloading. So I was left wondering, how is that process is being abused to do all of that malicious stuff? And my clue was hidden inside the command line. So you can see the command line starts with code.exe tunnel. So I was trying to understand what that command line means. And apparently, this is a feature of VS Code CLI. It enables users to use remote tunnels to connect to remote machines via a VS Code client. Basically, developers can write code on a remote machine from anywhere in the world. Now, if you are a legitimate developer, you are probably now thinking to yourself, hey, this is a pretty cool feature. I can develop my code from anywhere I want to. But if an attacker is abusing this feature to get a hold of your environment, it's a bit less cool. It might even get you a seal of disapproval, and nobody wants that. Now, as part of my investigation, I was trying to learn more about the technique and to see if it was ever used in a past attack. And at the time of my research, I did find a POC that described how the technique works. It was published about half a year prior to the attack that I was investigating. But at the time of my research, there were 0 reports about this technique being abused in an actual malicious operation in the wild. Now, as a researcher, it was pretty exciting to understand because it was like witnessing the first time abuse of this technique in the wild. But what is interesting is that if you search for the abuse of the technique today, you will actually find several reports about several different threat actors who are abusing this technique from recent months. So it really looks like this technique became more and more popular, which is why it is so important that we know about it, know how to recognize, how to mitigate, and how to prevent it. So now I want to show you a live demo of how the abuse of these techniques looks like from the side of the attacker. And hopefully everything works out network-wise, but worst case scenario, we do have a video of a recording.
Yeah, but this is going to be hopefully a real live demo.
Yeah, so I'm resuming my Victim virtual machine here.
I prepared 1 or 2 dead jokes.
Just in case.
Just in case.
Oh, that is great. Okay, let's hope everything works. So in order to make the technique actually work, the attacker actually does need some sort of remote code execution, the infected machine. So for the demo, let's say I got some fake PDF file on the infected machine via phishing. This is, of course, not a real PDF file. It is actually a LNK file that executes some PowerShell code in the background. Now the user will press it, and hopefully it works. We don't have any network problems, but it appears that we do. Okay, now it is loading. Okay, I don't want you to wait too much time because everything started to loading, so I'll just show you the recorded video. So we have our victim machine, as I said, and we have the attacker suppressed on the file. Now the code in the background is going into my server and is getting the VS Code CLI. It is downloaded on the machine and is executing it. And what you see here is it was actually uploaded some file to my machine, this upload file.txt. And the reason I need this file is actually for the technique to work. I need to log into GitHub, to that domain over here. I need to insert the code that I got from the infected machine. So I needed to input the text into a file and upload it to my server. After that, I will get into this domain and insert the code. Okay, and this is basically it. Now we go into the VS Code.dev domain. Sometimes we need to refresh the page for a minute for the connection to work, but we're basically now supposed to have a tunnel into the remote machine. We have a tunnel into the victim machine. We can just open it. We have a nice VS Code UI. And in a second after it loads, we have a terminal. Just as you can see, we can execute command on the victim machine. And we can echo some, no, I don't want it to, and we can echo some, we go to the desktop and we can echo some text into a TXT file. So you see that I have a remote shell on the machine. And the file was created on the remote machine. Now we have also other different capabilities we get from using VS Code. We can actually use it as a file explorer and basically see all of the different folders inside the machine, which is great for an attacker. In here, I went to the user folder because from here I can see a bunch of different folders and files. I can see the desktop files right here, as you can see. Those ones that I created, and let's open the documents folder. And here I can see some password file. I can just open it. I can see some very secret PDF files, and I can just download it, as you can see, to my machine. Works flawlessly. And I can also upload files to the victim machine through that. So let's upload some very bad file. As you can see, it was uploaded to the desktop. And again, it is on the desktop of the victim machine. And of course, this is just a TXT file, but an attacker can upload malware using that. And of course, this is VS Code, so I can also write code using it. So let's create some very bad script, .bat, on the victim machine. I'm using some code that just writes text into a demo.txt file, just so you see that it works. And I'm going to the desktop again, so we can see that it's going to be created on the desktop. We can run active file, and the script is just running on the victim machine. And again, the demo.txt was created. We can see it on the victim machine. And the bad file was also uploaded to the victim machine. So as you can see, this technique, which is supposed to be, of course, everything is legitimate, it's a legitimate application, gives the attacker basically full control of the machine. They can get a reverse shell, they can upload and download files, they can create scripts on the infected machine. And everything happens from a legitimate application inside the network. So now that we see how simple it is to use this technique, let's talk about what we can do to actually detect and prevent the abuse of VS Code tunnels. So we have a lot of different options. And of course, the first option, we can just completely block VS Code CLI inside our environments. But that might be a bit extreme for some of you. So of course, we have other options. A second option is you can limit access to the different VS Code tunnel domains inside your network. And that will also essentially block this feature from working inside your network. Now, in our team, we really love to do threat hunting, so we have some options for that as well. We can monitor for activity where the command contains code.exe and tunnel. And a second option is to monitor for process trees where CMD or PowerShell was spawned from a code.exe parent process. And yet another option that we can use is to just disable the use of dev tunnels via GPO, which is a feature that Microsoft added. So as you can see, we have a lot of different features, options to try and detect and prevent the technique. And you can just choose the ones that work best for you. Okay, so in this presentation, we went over 6 different case studies. Each one is talking about a different technique to abuse an IDE. Some of them was how North Koreans abuse GitHub, how Chinese APTs abusing VS Code CLI, the threat behind malicious VS Code extensions. So now I'll pass the stage to Daniel one last time to give you some final key takeaways that we have from all of our research.
Thank you, Tom, for the last time today. Well, first of all, as we saw, nation states and also cyber criminals are abusing all kinds of IDEs to eventually try and remain under the radar. So this is a very efficient technique because, as we saw throughout the presentations, they are running in the context of a legitimate application. And the second thing is that besides running under a context of a legitimate application, they can use different technologies. Attackers can use different repositories, different programming languages, and just kind of implement different technologies to abuse IDEs and fly under the radar. Now, we also saw that developers are eventually prime targets. And this is due to the fact that they have so much access to sensitive resources as a company's source code and other proprietary information. So they make really good potential victims for extortion and also for cyber espionage, and also to attackers can try to steal source code through compromising software developers. Now, this leads us to the third key takeaway, which is the human factor. As for now, most of the developers are still human, and humans are the weakest link, right? And this is why it's so important to periodically conduct cybersecurity awareness trainings for employees in general, and specifically for software developers in such cases that we showed you, just so that the employees will be familiar with similar threats and know how to handle them. The last key takeaway is this. We showed you a lot of these apply slides throughout the presentation, so we strongly encourage you to take these recommendations and try to implement them in your organizations to try and improve your security posture. This is it from us. Thank you so much for attending our talk. And if you would like to read the related research, all the links are scattered throughout the presentation. There are several blogs that demonstrate the research that we showcased here. And we're here for questions.
Thank you so much. Do I handle it, or do you handle it? Okay.
Hi, everyone. If there's questions, you guys can come to the mic in the front, and they will be answering.
Okay. Yes.
Thank you for your presentation.
Thank you.
I'm just wondering, with some of the repositories, did you do any static application security testing or SCA security composition analysis or anything like that? And if so, in your pipeline, would that have found any of the malicious code that you had in your repositories or not? Was it obfuscated enough it wouldn't have found it?
Well, some of the attackers try to obfuscate it, but in terms of the first part of your question, so We are doing research. I mean, so we did not test out these repositories in terms of what you asked, but we just like ran through them and try to understand how they try to conceal the information and what malicious repositories we can find in general. I hope that answers the question.
Sort of. But just wondering, let's assume somehow some malicious code did get in there,
Okay.
right? Developer inadvertently, downloaded some packet, there was something there. I'm just wondering with any of that, if you had any SaaS tools with Veracode or Fortify or any of the tools that scan your source code, and if it would have found it or not was kind of, I guess, that would be an interesting thing, because a lot of us, corporate companies build some of that testing into the code to make sure it goes through the pipeline. And I'm just wondering if it would have found any of it.
That's an interesting question. We haven't tested it out against some solutions, as you suggest. In our team, we're focused on improving the detection of our product, but we have an EDR product, so we know how to detect these threats, with our EDR product. So we did not, I believe probably it can be done, I guess, with the right adjustments, but we did not test these malicious repositories against products that supposed to scan these malicious code.
Yes.
Thanks for the session. Just a quick, so when we talked about VS Code, is there specific IDs, like there are forked IDs, like from part of VS Code, like Cursor is a fork of VS Code. So is those IDs also have a similar vulnerability?
IDs like VS Code?
Like VS Code, like Cursor, there is a Cursor IDE, a lot of other IDEs like Windsurf, IntelliJ.
I see. So regarding the vulnerability, it is a feature of the VS Code CLI. I didn't check other IDEs, mainly the VS Code CLI. And also for the extensions, I guess if any IDE can get extensions, it could be a malicious extension. So okay. It is a threat that every IDE who has an extensions can have.
Okay.
Yeah, malicious extensions are malicious extensions, either for IDEs, browsers, or whatever. And about similar IDEs, so eventually what's being, it's a feature. What's happening, like more technically, in the background is like these XML files that you saw in one of the examples. So there is just like code that can be executed from these CS proj files. So I'm guessing that if other IDEs will allow for code to be executed from these files, I guess maybe it could be done. As Tom said, we did not test it out, but it all relies in it's not vulnerabilities or anything. It's just like features that allows attackers, to kind of get inside of these loopholes and use them for their benefit.
Sure. And part of recommendation you talked about disabling a tunnel kind of a feature. Is it part of VS Code itself, or is it a network level config?
No, it's through the Windows, not VS Code itself.
Oh, it's part of Windows operating system. Yeah. Okay, sure. Thanks.
Hey, thank you for the presentation.
Thank you.
This attack, the kill chain, seems quite complex compared to simple ransomware where you directly infect a machine. How big the problem is in your opinion? Is it a nation state thing, or how big you would judge it is currently?
Can you repeat the question? I didn't hear it.
How big is the problem at the moment? Because the attack is so complex compared to simple ransomware attacks. How much should we care?
How much should we care? Because it's a more complex attacks to, let's say, in contrary to ransomware attacks. So these are more complex attacks. And,
okay.
And your question is like, how common is it, or
how common is it in the wild?
Well, we saw at least a couple. I mean, these use cases, we had like 3 or 4, I think 3 distinct clusters of activity that's operating on behalf of North Korea. So, and they all, I mean, we separate them and we track them down as different clusters, but they all use the same technique of trying to we also didn't talk about like malicious NPM packages that they're trying to do, and so we have Python, we have C#. So it's pretty common, and I think threat actors are using it more and more. And they also think that it's more common for nation states than, let's say, cybercrime, because as you said, it requires, like a lot of resources in terms of, crafting these social engineering schemes and approaching developers. So it's more of a nation-state thing, you can say.
And also, let me add to that, as I said, the VS Code CLI abuse that I saw, a year ago I didn't find any report about it being abused. But again, I checked like a week ago, and there are several reports about it from like the past 6 months. So it really looks like attackers are using those kind of techniques more and more.
So you have seen 4 cases within a certain time frame, in 1 year, or how long?
Less, I think maybe like 6 months, I think. I don't remember the exact dates, but it
was a few months, but also we also just picked and chose a few cases. There are more, of course, we don't have time to get in this session.
Yeah, you can actually see the release dates on the blogs, so then you can correlate, like the time frames sort of. So, but yeah, it was like a couple of months of a time frame, which also indicates of this like rising activity. Thank you.
Okay, thank you. Are there any more questions? Okay, then I guess that's it. Thank you so much, everybody.
Thank you again.